Welcome to the final lesson on the circle. In this lesson, we want to look at how to find the equation of a tangent to a circle. We're going to do that using some ideas around the straight lines involved. So if you look at the diagram on your screen, we should be familiar with the idea that we can draw a radius which is perpendicular to a tangent. Which means if we look at the gradient of the tangent, m tangent, and the gradient of the radius, multiplying these two together will always produce the answer -1. So m tangent times m radius will equal -1. Perpendicular gradients have that property, and the radius and the tangent are perpendicular. We, of course, need some points in this type of question, so we need usually to know the center of the circle and a point of contact. If we have those 2 points, we can always use the gradient formula to find the gradient of the radius. Therefore, we know the gradient of the tangent, and we also know a point on the tangent. With those pieces of information and our equation of a straight line, which we remember as y minus b equals m bracket x minus a, we will be in a position to determine the equation of that particular tangent. So let's look at some examples of this in practice. In this first example, we're going to show that a particular point lies on the circle that we're given, and then find the equation of the tangent to the circle at that particular point. So the first idea we've looked at previously, just demonstrating that a point lies on the circumference of a circle, and the second idea is the main element of the lesson that we're looking at today. So what we want to do is to substitute the point P for -2 into the equation of the circle, just to show that that actually does satisfy that equation. So we substitute x is 4, y is -2, and if we substitute that point and calculate what we get on the left-hand side, it should equal 0. 4 squared is just 16, -2 squared is just 4. Here we've got 4 times 4 is 16, -12 times -2 is plus 24. We subtract 60 and it should equal 0 if it lies on the circle. And sure enough, if we tidy up the left-hand side, it does equal 0. So we've proven that that point does lie on the circle. So hence, the point P lies on C, the circle C. What we really want to do then is to find the equation of the tangent at that point. To do this, we're going to need the point, of course, but also the center of the circle. So the point is 4, -2, and the center, of course, we can work out from the equation. We've looked at that in previous lessons. So the center of this particular circle is -2 and 6. Using these 2 points, we can now find the gradient of the radius. So m radius, or m rad, would equal, and that would be y2 minus y1, that would be 6 minus -2, divided by -2, take away 4. That gives us the answer 8 over -6, or -4/3. And here's the important part. Once we find the gradient of the radius, we use the property that these two multiply to make -1 to find the gradient of the tangent. So m tan would be, of course, what would we multiply -4/3 by to make -1? It would be 3/4, the negative reciprocal. We now use our equation for a straight line where we have a, b, and m. It's important here to focus on which point to use. Of course, only one of these points is on the tangent, and that is the point of contact. So we do not use the center here, we use the point P. So x is 4, y is -2, and the gradient is 3/4. Simply substituting that into our equation will yield the final answer. So just being careful with negatives, also multiplying everything by 4, just to remove the fraction here. 4y plus 8 equals 3x, take away 12. So 4y will equal 3x, take away 20. And that would be the equation of the tangent that touches that circle at the point P. Let's look at that process again in example 2. We'll go straight to finding the equation of a tangent. So we have the equation of the circle and we have the point of contact T. So we'll write down first of all the center of the circle. So we identify that from the equation. The center here would be 3, 2. And we can also see the point is T, which is 1, 6. So we're now ready with this information to find the gradient of the radius and therefore the gradient of the tangent. So as before, mrad will be y2 minus y1 over x2 minus x1. 6 take away 2 over 1 take away 3. We have a negative gradient here. 4 over negative 2 is negative 2. We deduce then that the gradient of the tangent must be 1/2, as those two multiply together to make negative 1. We could just show why we've got that result here by just making it clear that we understand that these two are perpendicular. Again, we just need to write down our checklist for A, B, and M. And just make sure we don't use the wrong point. We're using the point T here. So A is 1, B is 6, M is 1/2. And really, this is now an easy step in the process, just using the equation of a straight line. Y minus B equals m bracket x minus A. And here it's x minus 1. And we just multiply everything by 2 here to make life easier. And then we add 12 to both sides. And that would be an acceptable form for the equation, 2y equals x plus 11. In our final example in this lesson, we'll look at a slightly more complicated problem where we have to find the equation of the tangents to a circle, and we know that these tangents pass through the point 0, 1. We don't have the point of contact, so we have to be a little bit more careful, and we have to think about, first of all, the fact that every straight line has the equation y equals mx plus c. So from that starting point, we can think about the fact that we know the y-intercept for this particular tangent here would be 0, 1, or for these tangents, sorry. So they must be of the form y equals mx plus 1. We don't know the gradient of each tangent, but we can find that now by substituting that equation into the circle. So we've looked previously at how we can substitute the equation of a line into a circle. I'm going to do that now. And we normally do that to show that it's a tangent. Well, here we know that this is a tangent, or that these lines are tangent to the circle. We just want to find the value of m. So you can see that having substituted the values in, we can now break the brackets. Here we're going to have m squared x squared plus, there'll be 2 lots of mx plus 1, take away ax, take away 2mx, take away 2, and plus 9 equals 0. If we now group together the first 2 terms, because we have m squared plus 1 lots of x squared is really the common factor here. We actually have plus 2mx and minus 2mx, so they will cancel. So we only have now negative 8x as our coefficient of x. And the constant terms, we have 1, take away 2, plus 9, which is plus 8. So plus 8 equals 0. We have our quadratic, which we always have in the situation of putting the equation of a line into the circle. We just still don't know the value of m. But now, if we write down a checklist of a, b, and c for this quadratic, so a being the coefficient of x squared, b is the coefficient of x, and c is the constant term, then we can recall that in the quadratic theory chapter, we know that if a quadratic only has one solution, then the discriminant b squared minus 4ac must equal 0. Because this is a tangent, there's only one solution to this quadratic, which means that the discriminant must equal 0. If we now input those values carefully, we'll be able to solve for the value of m. In this case, the values of m. 64 minus 32m squared. Take away 32 must equal 0. Solving further, we have that 32m squared equals 32. So m squared must equal 1, or m equals plus or negative 1. So actually there are two values for m, as we were hoping, because we need the equation of the tangent at either side of the circle. We need two tangents here. So one of them would be y equals x plus 1, and the other one would be y equals negative x plus 1. And that's the equation of both of our tangents. It's a good idea to see visually what's going on here. I've mentioned before that Desmos is a good package to use, so that would be one option. We could sketch the situation here, but if we just quickly use Desmos. So here is a very basic sketch of what's happening. We have a circle. It does have two tangents, both of which originate from the point 0, 1, or certainly pass through the point 0, 1. One of those tangents, we can see the green line here would be y equals, clearly that one is x plus 1. And the second tangent has a gradient of negative 1, it's negative x plus 1. So I would highly recommend that when you're working with circle problems, you think about the geometry. Using Desmos is a great way to sketch these, or certainly to help you with your own sketches, and just to see what's happening. We've now come to the end of this lesson, and indeed this series of lessons on the circle. It's now your chance to get some practice on this technique. Here are the pages from the textbooks that you may be studying. For TJ, page 82 will have some practice on today's lesson, and then I would suggest you try the mixed questions on page 83, questions 1 to 15. For Heinemann, you want to start with exercise 12L, and then following that, there'll be some other opportunities to get some practice across this topic. This has been lesson number 5 of 5 lessons. Do make sure that you've caught up with all of those. They will help you in your study, I'm sure. You will need to get some help from your teacher now that you've completed the topic, and obviously try some exam-style questions. Good luck with all your study. I'm sure you've got this.